We are P10 Team 3, and today we'll be introducing our abstract engine and game. After our last submission, we identified and addressed several key issues to improve our game engine. First, we faced multiple path dependency, where several classes were relying on a single class. This resulted in complex dependencies and made our system harder to scale. To tackle this, we implemented dependency injection, allowing for more modular and flexible design. This approach decouples classes from each other, making the system more adaptable and easier to test. Next, we encountered tight coupling, where classes were too dependent on each other. By introducing the factory design pattern, we now ensure that entity creation is isolated, preventing direct dependency on specific implementations and hiding internal details that shouldn't be exposed. Lastly, we had an encapsulation principle violation, where private attributes were being exposed. The solution to this was the singleton design pattern, which ensures that components, especially those that needed to be globally accessed, are instantiated only once.
Hi, I'm Ernest, and let's dive into the distilled key aspects of our abstract game engine. Firstly, we have focused on building a modular architecture. Our engine is built on a manager-based approach where dedicated managers handle scenes, entities, audio, and more. This design ensures that each system has a clear independent role. By leveraging interface segregation, such as with our I entity manager, we keep responsibilities well defined, and this not only reduces complexity but also enables independent development of components. Secondly, we have prioritized extensibility. We've adopted an interface-based design, which means that our components can be seamlessly integrated without altering our core systems. This provides us with the flexibility to adapt and expand the engine as new requirements emerge, ensuring long-term scalability. Lastly, we have used two key design patterns to underpin our architecture. First is the singleton pattern, which guarantees that critical components like the output manager are only instantiated once, ensuring consistent global access. Secondly, the state pattern simplifies the addition of new game states, and when combined with our centralized scene creation, allows for smooth transition between states, which not only streamlines development when new features are added, but also enhances the user experience. Together, these principles create a robust, adaptable foundation, making our game engine both efficient and good for future development.
Okay, so here comes to our simulation lifecycle management. So when the simulation starts, the core managers are instantiated in the game master. The game master calls the scene manager to render the scenes. Scene manager switches the scenes by receiving the customized enum. And when the scene manager switches the scenes, it calls the show method of the scene for initialization of the scene, the entity creation, and to show the scene. Before the initialization starts, all the managers clear the entity list before the creation starts. The entities are created in a bundle using the entity factory and being retrieved in the scenes. The entities, after creation of entities, they are being added into the corresponding managers, such as the collidable entities are being added into collidable managers. The movement and the collisions are updated, and the simulation draws the entities when the scene is rendering. And last but not least, when the program closes, all managers, including the scene manager, collidable manager, and the movable manager, dispose all the components in their classes.
For our game engine scene management, we first have our game state that defines all game states and is used to trigger scene transitions. Next, we have iScene Manager class, which is an interface. It acts as a contract for scene management. Its methods include switch to scene that utilizes game states, render, dispose, and set screen. Next, we have our scene, which is an abstract class that acts as a base for all scenes. Next, we have our Scene Manager, which is another abstract class that implements iScene Manager and manages the active scene. It also helps to handle scene transitions and game states. Next, we will now go through the implementation of base menu, story, game, and tutorial screens. For this, we will use base menu and story screen as an example. So the purpose of these base screens is to act as an abstract base class to avoid code repetition. Some of the key features of menu and story screen include being able to customize background or portrait images, as well as the text in the skip button, as well as where it clicks to. Next, it provides dynamic UI, which means the automatic scaling of portraits to fit each user's screens, as well as the wrapping of text with custom font styling.
Hi, my name is Kaho, and I will be presenting the collision management system in our game engine, which plays a crucial role in handling interactions between entities within the game world. It was designed with scalability, reusability, and modularity in mind. The entity component system enables efficient collision detection and response, ensuring smooth interactions between different game objects. The engine employs a layered approach for collision handling. Collidable Manager oversees all collidable entities and ensures efficient pairwise collision detection. Collision resolution is handled by multiple classes. Firstly, movable collision manages interactions between dynamic entities. Next, static collision ensures static entities remain fixed while adjusting colliding movable objects. iCollidable is an interface that enforces a standard collision behavior across all entities. Each collision is resolved by calculating axis overlap and adjusting positions to prevent clipping or pressing through objects. The movable adders class ensures sprite animations sync with movement, maintaining visual consistency.
Entity lifecycle management is a critical concept in game development that defines how game objects are created, maintained, and destroyed throughout the game's runtime. Entity lifecycle consists of three primary stages: initialization, active state, and destruction. During initialization, the entity factory plays a crucial role in object creation, using configuration parameters to instantiate entities with specific properties such as its position, size, animation, etc. etc. The initialization process involves assigning the entity to appropriate managers like the Collidable Manager and Movable Manager, which track and update the entity's behavior. In the active state, entities undergo continuous updates, including position calculations, collision detection, and state changes based on game logic. The entity manager oversees these updates, ensuring each entity performs its designated functions efficiently. Throughout this stage, entities can transition between different states, such as a text block changing from inactive to active when interacted with. The destruction phase occurs when an entity is no longer needed, triggered by events like falling off screen, completing objectives, or colliding with specific game elements. During destruction, the entity is removed from managers, freeing up system resources and maintaining optimal performance. The level config and entity bundle classes demonstrate this lifecycle management by providing mechanisms to create, configure, and manage entities dynamically across different game levels.
Next, for the behavior portion of our game engine, we have the enemy movement class that controls basic movement directions of enemies. Their movement type is specified by the movement type enum. Next, we have the player movement class that handles key press detection, manages movement feedback, as well as provides automated player movement. For our game engine's input control, we first have the input manager that acts as a centralized keyboard input handler. It helps to manage directional controls, typing input, and action buttons. Next, we have the iAlphabet keys interface class that acts as a contract for modular keyboard handlers, and it uses the getAlphabet method. All this will be used in base game and tutorial screens to help handle user inputs.
Our game is an educational typing game that integrates platform mechanics to help children learn the fundamentals of touch typing. Touch typing is a technique that enables users to type efficiently with all 10 fingers, while looking at the keyboard, relying on muscle memory to improve speed, accuracy, and overall typing proficiency. By engaging players in an interactive gaming environment, the project aims to make typing practice enjoyable and educational. The team's use of AI primarily falls into three categories. It significantly aided in debugging by identifying potential issues, such as highlighting areas to investigate when resolving collision detection errors. It clarified class concepts like the factory design pattern while proposing implementation approaches that led to the creation of the level manager and entity factory classes. It also provided valuable insights during code reviews, suggesting potential improvements to enhance code quality. Okay, so now we'll be doing a demo on our type touching game and showcasing how it works. This is the first tutorial screen before the first level, and it basically trains you to be more proficient at typing with your left hand. As you can see here, the characters I'm typing here are all aligned to the left side of the keyboard, but I'll skip the tutorial for now. The first level here has the text Cat and West. In order for the auto-moving fox character to proceed to the next level, I'll have to type the characters out with my left hand to form a bridge, as you can see here. This is a second tutorial screen to train my right hand typing. Similar to the first tutorial screen, I'll skip the tutorial. This is the second level and it has the enemy slime in the middle. As you can see, if the fox character falls to the ground and touches the slime, the level restarts. Finally, the last tutorial trains both hands to type. I'll skip the tutorial here as well to move to the third level. Okay, so I'm typing out the words fox can jump to form the platforms. This level also showcases that the spacebar can be pressed so that the fox can jump over the platform to move on to the last level. And here it is, the final stage. Once the fox moves to the end of the screen, the victory screen shows up. Our team has developed an educational typing game designed to help children learn the fundamentals of touch typing through engaging platform mechanics. The game encourages learning by turning typing practice into an interactive experience, progressively increasing difficulty as players advance through levels. The game incorporates multiple word layouts and provides real-time feedback to improve typing speed and accuracy. To support this, we have built a game engine focused on flexibility and scalability. The engine follows object-oriented principles and consists of key components like collision management, input handling, and scene management. These components are modular, reusable, and work seamlessly with the game layer, which handles specific game logic such as the entity management and level progression. Throughout the development process, we implemented various design patterns to ensure maintainability and flexibility. The singleton design pattern ensures critical components like the output manager and level manager are instantiated only once, while the factory design pattern abstracts entity creation, allowing for easy expansion. Since our last submission, we have improved the engine by addressing issues related to type coupling and encapsulation violations. We have applied dependency injection to decouple classes and improved the modularity of the system. These improvements ensure that our engine is more flexible, easier to extend, and better prepared for future updates. In summary, our game provides an interactive, enjoyable, and educational way to learn touch typing, while the underlying game engine ensures a scalable and maintainable system for future development. Thank you.